Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at functors in C++. Functors are another way of passing blocks of code to functions, basically. They're kind of an alternative to function pointers. And they have some advantages, like there are some things you can do with functors that you can't do with function pointers, but function pointers are more convenient for other situations. So this is kind of an alternative thing you can use. In C++11 we actually have lambda expressions, which are a form of syntactic sugar really for functors. But in this tutorial we're going to look at the pre-C++11 syntax, which also works in C++11. It's also important there, which allows us to pass blocks of code around basically in variables. The way this works is, well, let's imagine we've got a function, I'll call it check, and this is going to test some kind of, I don't know, let's take a string as an example. So it's going to test this string, apply some kind of test to it, and it's going to do something with that. So check could be a function that tests a whole array of strings or whatever you like really, but I'm just going to strip this down to its kind of simplest elements here. So I won't use an array, but the idea is check has to perform some sort of test on one or more objects. So we'd like to be able to pass some kind of test to that check, some kind of predicate that says yes, this string or this object passes that test, or no, it doesn't. We've seen that we could do that with a function pointer. We could have a function pointer parameter here. We could pass a function to check, which check uses to do the test on this string or whatever kind of object we have here. Another way is to use a functor. So let's create a class here, a struct. Well, yeah, I'll use struct because we could use a class, but with a class, by default, all the methods and variables are private, and in a struct, they're public by default. So it's maybe just a little bit nicer in this particular case to use a struct. So I'm going to use a struct, and let's call it something like match test or something like that. So the idea is this is going to contain some code that can test some particular object, like a string, and say yes, it passes our test, or no, it doesn't. And this could be a particular test. We could say, okay, this is a test that returns true if the string matches some particular text, and false if it doesn't. Of course, this is a very complicated way to do what I'm about to do, but I just want to show you the principle, and then you can apply the principle in lots of situations where it becomes a lot more powerful. You know, checking an array or something. So we can actually overload the brackets, the round brackets operator. So this bit here, the argument list on a function, or there's another example here actually, is actually an operator. The round brackets are an operator, and they're different to every other operator in C++. In that they can take a variable list of arguments. They can take no arguments or as many arguments as you like, basically. Although they get unwieldy if you're supplying lots of arguments. So the round brackets operator is the only one that can take a variable list of arguments. All the other operators, they take either 1, 2, or 3 arguments, or none, I suppose. Well, no, actually, they'll take 1 because they've got to operate on something. Okay, so we can overload the round brackets operator here. So we're going to overload this just like we overloaded other operators. We have the operator keyword, and we have round brackets, and I'm going to make this return bool. So we can make the round brackets operator return whatever we like, actually, but I'm going to make this one return bool. And now after saying operator round brackets, now we have the argument list, and that can be as many arguments as you like. So there's another pair of round brackets. This is just to specify what operator we're dealing with. the empty round brackets, and this is where you put your argument list. So it looks exactly like overloading plus or equals or something. It's just that we can choose the return type here, which is, I guess, not the case with every operator. And or is it? No, it's not. Okay, and here we are going to put the arguments just like we would with overloading any other operator. So what do we want the arguments to be? Well, in this case, we want this operator to perform a test, and in this case, we're going to say it's going to test a string. So we can put string, let's make it a reference, string reference text. Doesn't have to be a reference, it's really up to you. It depends how you're going to use it. Whether you're going to use it on variables or literal values, basically. So now we can test this string somehow. Let's say return text equals lion, let's say. So this is a check to see whether the text is equivalent to the text lion, whether it's the same. Now this is called a functor. So a functor it's a class or a struct that, among other things, whatever else it might do, it overloads this these brackets operator. So usually you think of a functor as probably not having much to it apart from this overload, but there's no reason why it can't have more like private variables or methods or whatever you like. You can add more stuff in there if you need to. So how do we use this? Well, it's actually rather interesting. So we can declare a match test object now. Let's call it. I'll call it pred for predicate. Meaning something that tests something, basically. And now we can use this. It looks like a function because we've overloaded this round brackets operator. So, I've made this a reference, so I can't use a literal value here. Let's say string value equals lion. And let's say pred. So that's the object. And we use the round brackets operator and pass in our string value. And let's just output the return value of that here, like this. So this looks like a function call, but it's not. It's really the it's really the round brackets operator being applied using this object to this value. So it's kind of interesting the way it resembles a function. And if we run this now, we expect to see 1 there because it does match lion. And if we make it so that it doesn't match lion, we expect to see 0, meaning false. There we go. So this works. And this is a very complicated way of doing this, but we can pass it to other functions, effectively passing around this block of code. So to do that, well, the idea is here that check, maybe check can apply different kinds of predicates, different kinds of tests, and we want to be able to pass different kinds of tests to it. So we can achieve this by having a base class of match. Let's say I'll use a struct again, but we could use a class, and I'll call it test, like this. So here's a base class. We could make it abstract. We could say that it's got to have this method, and it's a pure virtual function like this. So say bool. Let's say virtual bool operator brackets equals 0. So this is now an abstract class, and we can make match tests derived from this. Let's just check the warning. So it's complaining that there's no destructor, which we don't need, but I'm going to just implement it just to get rid of that warning. So we can make match test derived from this. We can say public test. So match test is a kind of test. Let's see what it's complaining about now. I didn't make the constructor virtual. There we go. So in the argument list for check, we can now pass in a test reference. It must be a reference if we want polymorphism to operate correctly. If we want to pass in different kinds of tests, like this one, for example, and have it correctly call this method, we need to work with a reference or a pointer. And we can make this virtual just to emphasize that it is virtual, although we don't need it because the virtual keyword is on the base version of this. And we can pass in, let's call that test or predicate or something. I'll call it test. Now we could say here, if test, and we use it like a function. So here we're using this match test operator, brackets operator, and we can pass it this text, and we can say, we could do something here, like something, I'll just do something really simple and trivial, just to illustrate the concept, like this. Endler, else, cout, no match. So of course this check function, it could count the number of occurrences in effect, or it could do whatever you think is appropriate, really. Or you could use this for stuff like timing code. This could contain code that you want to time. You don't have to return bool, you don't have to take this parameter, it could be different. And check could time code that's passed in like this. So let's try this now. So we can say check lion, and we need to pass a instance of match test here. So if we did this, I don't think this would work, because we're literally here, we're trying to supply like an object we've created on the fly directly, and we're trying to pass it as a reference. So that's not going to work. But we could do match test m and then pass in m. So this should work. So we can't supply like literal values if we have a reference there, but this is going to work. So if we run this now, we see that text matches, and if we put in something else, we should see that no match. So that, of course, the idea here is we could implement lots of different tests that all derive from this, and we could pass them to this function here. So we're making use of polymorphic kind of references in order to implement this functionality. This has, there are some things you can do with this that you couldn't do with a function pointer. Like, for example, this could actually have a state for it. If for some reason you needed this to have a state, it can have private variables, for example. In some ways it's a little bit nicer to work with than function pointers, but that kind of depends what you do. So this is just worth knowing about as another string to your bow, particularly because it can really confuse you if you see where are we, this kind of thing going on. You think, well, test must be a function, but as we can see, it doesn't have to be a function. It could actually be an object. Well, it could actually be an object, which this is. Okay, so that's it for this tutorial. I would suggest just trying this for yourself. Try using this overloaded brackets operator. In other words, try creating a functor and using that to pass some code to a function, which then does something with that code. So just check you can do that. If you want, you can make it test something. You can make it do some kind of test. But if you can think of any other use, as long as you can kind of demonstrate that you're able to pass code to a function using this technique of functors and execute it, this is a functor, then you're in good shape. You don't have to have this base class, but because it enables you to do stuff like this and then pass in any base class, any derived class, this is quite a common and useful thing to do. Okay, that's it for this tutorial. Later on we'll look at C++11 and we'll look at lambda expressions, which are another kind of simpler alternative to this in a way, which lets you do this with a bit less code, although at the expense of looking initially a little bit more impenetrable. Well, that's an arguable point, because this already looks a bit impenetrable till you type it out and you practice it. But for now, I'd suggest just having a go at that. Okay, so until next time, happy coding.